Okay, this is from exercise 2b. Now he is asking here to find the equation of radical axis. We know that radical axis equation is nothing but s minus s dash is equal to 0. But in s minus s dash equal to 0, both s and s dash are in their standard form, in the sense the coefficient of x square is 1 in both the cases. Observe that here the coefficient of x square is not 1. So first we make coefficient of x square to be 1. For that, divide it by 3, and then you will have the equation as x square plus y square minus 7 by 3x plus 8 by 3y minus 11 by 3 equal to 0. Now this is your s dash and this is your s. Now go for s minus s dash equal to 0, you will get what you want. Let's go to next problem. Similarly, you can do the other parts of this problem. Now look at this problem. We know that again equation to the common card is also s minus s dash is equal to 0. Just find that. Now second Roman first one. He is asking for the common tangent at the point of contact. We know that when the circles are touching each other, whether they are touching externally or internally, equation to the common chord is nothing but common tangent at the common point is nothing but s minus s dash equal to 0. So you just go for s minus s dash equal to 0, you'll get what you want. Let's go to the next problem. This problem actually it should belong to exercise 2a. You are not finding any common tangent at the common point here, at the point of contact. You see, in the second problem, he just asked us to show that the circles touch each other and find the point of contact. That's all. Okay, now we know what to do to show that the circles touch each other. We have to calculate C1, C2, R1 plus R2, mod of R1 minus R2. Those are the quantities we have to calculate. Now first C1, it is 4, 1. C2, it is 1, minus 3. R1, root of g square plus f square minus c. And R2, root of g square plus f square minus c. So we observe that this is 3 and here it is 2. Let's go for C1, C2. It is root of 4 minus 1 whole square plus 1 minus 3 whole square. So I am getting it as 5. So I observe that C1, C2 is nothing but R1 plus R2. That means we know that the circles are touching externally like this. Now for the point of contact, observe that this is R1, this is R2. So the point of contact is dividing the line segment joining center C1 and C2 in the ratio 3:2 internally. So for these 2 points, you apply the ratio 3:2 internally, section formula, you will get your point of contact. Okay, let's move on to next problem. Even this third problem should belong to the previous exercise. Anyways, he is saying we have to show that this condition is true if the circles are touching each other. Now, we know that the circles touch each other if and only if C1, C2 is equal to either R1 plus R2 or mod of R1 minus R2. Observe that there is nothing wrong in keeping mod to R1 plus R2. So, if C1, C2 is either mod of R1 plus R2 or mod of R1 minus R2, then the circles touch each other. Okay? So, this is true if and only if. Now here, let us look at the centers and radii. Observe that C1 is minus g comma minus f and C2 is minus g dash comma minus f dash, and r1 it is root of g square plus f square, and r2 is root of g dash square plus f dash square. So using those things here, I square it first. I'll get c1 c2 square equal to r1 square plus r2 square plus or minus 2r1 r2 I get. So this is if and only if g minus g dash whole square plus f minus f dash whole square is equal to g square plus f square plus g dash square plus f dash square plus or minus 2r1 r2. So I am getting, expanding the squares on the left hand side and cancelling the terms we can cancel. We have minus 2g g dash minus 2f f dash is equal to plus or minus 2r1 r2 we get. So this is if and only if, cancelling a 2 and squaring again, I have g dash plus f dash whole square is equal to r1 square r2 square. So this is if and only if g square g dash square plus f square f dash square plus 2g g dash plus, into f dash is equal to r1 square into r2 square. Now once again, if I expand this, if I take the product on the right hand side and cancelling the terms that are getting cancelled, you can see that g dash square will get cancelled with this, f dash square will get cancelled with this. So I'll be left with 2g g dash f dash is equal to g square f dash square plus f square g dash square. So sending everything to one side, I'll get g f dash minus f g dash whole square equal to 0. This is if and only if g f dash is equal to f g dash. Hence proved. We know that radical center is nothing but the point of concurrency of the radical axis. So I am writing radical axis of these two circles. Now first you know that I have to put it in the standard form, the second circle. So it is x square plus y square plus 3 by 2x plus 5 by 2y minus 9 by 2 equal to 0. So the radical axis is nothing but s minus s dash equal to 0. So I am getting it as 4 minus 3 by 2 into x minus 5 by 2 into y minus 7 plus 9 by 2 is equal to 0. So I am getting 5x minus 5y minus 5 is equal to 0, or that is nothing but x minus y minus 1 equal to 0. Now I am going for radical axis of these two circles. So I get 3 by 2x plus 5 by 2 minus 1, that is 3 by 2y minus 9 by 2 equal to 0. Or from this I am getting x plus y minus 3 is equal to 0. Now all the three radical axes, suppose these are the three radical axes. This is the radical center, they are concurrent and we know that is the. Now we have one radical axis and one more radical axis. Now you can see that these two are enough to find the radical center. You just go for point of intersection of these two. You can see that if I add them, I am getting 2x is equal to 4 or x is 2. And substituting this value of x in this equation, we observe that y is nothing but 1. Therefore radical center is nothing but 2, 1. Let's go to next problem. Okay, in this problem we have two circles. Now he is asking us to show that common chord of the circles is the diameter of this circle, second circle. Now we know that the common chord, it is nothing but s minus s dash is equal to 0, the common chord. So I am going for common chord. I'll get, subtracting one from the other, it's 2x plus 2y minus 14 equal to 0. So I am getting x plus y minus 7 equal to 0. Now we have to show that it is the diameter for the second circle. So to show that, we just show that center of this second circle lies on this line. What is the center there? Center is 4, 3. Now if I substitute this in this, obviously it is satisfying. Therefore it is the diameter of the second circle. Let's go to next problem. Now this problem, I think the second problem is obvious. For fun, I'll do one problem. I'm doing first part. It's asking for equation of the common chord and also its length. So I have s minus s dash equal to 0 is the common chord. So subtracting, I am getting 2x plus y plus 1 is equal to 0. Now you want its length. So you can take any one circle. So I am taking the first circle. The circle is x square plus y square plus 2x plus 2y plus 1 equal to 0. Now the common chord, this is 2x plus y plus 1 equal to 0. If this is AB, we want the length AB. What is the center here? Minus 1 comma minus 1. What is the radius? Root of g square plus f square minus c. 1 is the radius. Now we go for distance from center to the line. We know how to find this length of the intercept made by circle on a line. So going for the distance, I am getting mod of point in the line minus 2 minus 1 plus 1 by root of a square plus b square. So I am getting it as 2 by root 5. So if I call this foot as n, now I have an is equal to, from this right angle triangle ANC, applying Pythagoras theorem, it is root of ca square minus cn square. Now cn I got it as 2 by root 5. So I'll get 4 by 5. So I'm getting it as 1 by root 5 ultimately. So the length AB is nothing but 2 times an, which is nothing but 2 by root 5. 2 times an. Okay. In this problem, he is asking us to show that radical axis of these two circles is diameter of the second circle provided this condition is true. He gave us this condition. Now with the help of this, we have to show that radical axis is the diameter of this second circle. So what is the radical axis? First of all, we know that radical axis is nothing but s minus s dash is equal to 0. So if I do that, I am getting it as 2 times g minus g dash into x plus 2 times f minus f dash into y is equal to, plus c minus c dash is equal to 0. And you can see that the center of the second circle is nothing but minus g dash comma minus f dash. And now we have to show that this center lies on the radical axis to show that it is the diameter of the second circle. So we have to prove that this point satisfies this. Don't forget, he gave us one condition there. Now you can see that if I substitute the point in this, I'll get it as 2 into g minus g dash into minus g dash plus 2 into f minus f dash into minus f dash plus c minus c dash I get, substituting on the left hand side. Now to show that it satisfies, I have to show this is equal to 0. Now you can see that this is 0 if and only if 2g dash into g minus g dash plus 2f dash into f minus f dash is equal to c minus c dash. And that we know that this is true because that is what he gave. Hence proved. Now let's go to next problem. Now this fourth problem is similar to one of the problems that we have done just now. You see, to show that the circles touch each other, we have to show C1, C2 is equal to either R1 plus R2 or R1 minus R2 mod. Now, let us see whether if this happens. Of course, under this condition, we have to check whether this is true. So, to check whether this is true, let me first write the centers. C1 is minus a comma 0, C2 is 0 comma minus b, R1 is root of a square minus c, R2 is root of b square minus c. Now, this is true if and only if C1 C2 square is equal to R1 plus R minus R2 whole square. If and only if C1 C2 square is equal to R1 square plus R2 square plus R minus 2R1 R2. This is if and only if a square plus b square is equal to a square minus c plus b square minus c plus R minus 2R1 R2. And from this I am getting cancelling a squares and b squares. I have c is equal to plus R minus R1 R2 I am getting. Now this is if and only if c square is equal to R1 square R2 square. If and only if c square is equal to a square minus c into b square minus c. If and only if c square is equal to a square b square minus a square c minus b square c plus c square. Cancelling c square I am getting a square plus b square into c is equal to a square b square. This is true if and only if a square plus b square by a square b square is equal to 1 by c. If and only if 1 by a square plus 1 by b square is equal to 1 by c. And we know that this is true. So if and only if this is true. Hence proved. Okay. Now look at this fifth problem. We have to show that the circles touch each other. For that, what is C1? 1 comma 0. C2 minus 3 comma 3. R1 root of g square plus f square minus c. So I am getting 1. R2 is root of g square plus f square minus c. So I am getting 4. What is C1 C2? It is root of g square plus x1 minus x2 whole square, all that applying distance formula, I'll have it as 5. So I observe that C1 C2 is equal to R1 plus R2. That means the circles are touching externally. So I have the circles touching externally like this. Now you want the point of contact. So we observe that this is 1 comma 0, this is minus 3 comma 3, and the ratio is 1:4. Apply section formula for the line segment joining C1 C2 in the ratio 1:4. You'll get your point of contact. And you can see that the point of contact is internal. Obviously, circles are touching externally. The point of contact is internal to the line segment joining C1 C2. But the circles are touching externally. You see, this problem is obvious. Let me do one problem for fun. This is from direct theory. We know that if we are given 3 non-intersecting circles, and if we take the radical axis of these circles, they are going to be concurrent, and the point of concurrency is called radical center. And we know that from this point, if we draw tangents to the circles, they all have equal length. And if I go for the circle having radical center as the center and this length of the tangent as the radius, then we know that the circle so we are going to get is going to intersect all these three circles orthogonal. So we are going for that circle now basically. That is the required circle. So first we have to find radical center, then radius will get by taking length of the tangent from the radical center to any one of the three circles. First let us find radical center. Second Roman fourth problem is nothing but finding radical center only. We have done just now. Okay, I will do one of these problems. I am doing the last part. Fourth one I am doing here. Okay. If I number these circles as 1 and 2 and 3, you can see that 2 is not in the standard form. I have to divide with a 2 there because the coefficient of x square is 2. So it's x square plus y square plus 4x plus 3y minus 3 by 2 equal to 0. Now we will write the radical axis of 1 and 2. So subtracting one from the other I am getting y minus 5 by 2 equal to 0. Now let me write the radical axis of 2 and 3. Subtracting I am getting 2x minus 5y minus 3 by 2 equal to 0. Now solving, you see I have this radical axis and this radical axis. If I solve these two, I will get the radical center. So solving these two, substituting y equal to 5 by 2 in the second radical axis, I have 2x minus 25 by 2 minus 3 by 2 equal to 0. Or from this I am getting 2x is equal to 14. Or I have x is 7. Therefore, radical center is nothing but 7 comma 5 by 2. Now, let's go for length of the tangent. For that, I take the first circle. You can take any one of the three circles, you know that. We will get the same length. Now, we are going to take this length of the tangent as the radius. So, radius is equal to length of the tangent, that is root of S11. So for the first circle, with respect to this point, if I write S11, I'll get 49 plus 25 by 4 plus 28 plus 5 plus 1. I'm getting it as square root of 83 plus 25 by 4. Or this is nothing but root of 332 plus 25 by 4, which I am getting it as root of 357 by 4. Therefore, the required circle is nothing but the circle having this as the center and this as the radius. So it is x minus 7 whole square plus y minus 5 by 2 whole square is equal to root 357 by 4 whole square. You simplify this, you'll get the answer you are looking for.